Good afternoon, class. Welcome to week 7. Wow, it's hard to believe. Week 7 of the 15-week semester. So for today, we're going to go through the bond slides. I don't think we're going to finish them all. We'll get close to the end, but then we're going to do a couple problems kind of live on Excel like we did last class. This is where we ended up last week. We were talking about yields on bonds, and we're talking about that relationship when yields on bonds go up, the price of the bond goes down. And so this just shows some history of the yield to maturity on a 10-year U.S. Treasury bond, and you can see it hasn't been steady, right? And it's pretty crazy because we are somewhat in uncharted territory right now in terms of interest rates being so low, and yeah, people, it's hard to imagine that as low as they are. And that's why, a lot of people, mortgages are really popular right now because with consumer loans, you can pay off your loan without any penalty and get a new loan at a lower interest rate, right? And so that's really popular with people now with all kinds of loans. So it's something to think about if you're paying off a high interest rate loan right now. Looking at the option of getting out a lower interest rate loan to pay it off or get rid of the debt somehow, hopefully. And so that's with consumer loans, because by law, on consumer loans, you can pay them back. You can pay off your consumer loans without penalty, right? Any prepayment penalty. You can pay them off early without incurring any penalties. And you pay them back based on how much is left on the par value of your loan, if you will, right? But here's an odd little fact, with bonds, bonds don't really work the same way as consumer loans, and it's because of this fact how bond prices actually fluctuate. Okay. So let me give you an example. Let's say a company sells some bonds, right? And then interest rates fall. And so the CFO is thinking, golly, interest rates are much lower now. Why don't I just pay off my old bonds and then sell new bonds which have a much lower coupon rate, right? But it turns out because the prices of bonds float freely in the market, it makes no sense to do that. And the reason is this, right? Let's say they issued bonds a couple years ago at a higher coupon rate, right? And we know when interest rates go down, bond prices go up, right? And so this CFO, if he wants to pay off his old bonds, he has to actually go out on the open market and convince people to sell them, to him the bonds. And so there are going to be a couple problems. The prices of the bonds have gone up. So it's not like with a consumer loan, you can just pay back par value whatever you owe, right? With publicly traded bonds, the price has gone up. So any savings he could get by issuing new bonds at a lower coupon are actually going to be eaten up by the extra money he's going to have to buy back those bonds at the higher price above par value. And that's just that's a function of when you take out a loan by selling a bond, which is a publicly traded security. So that's why consumer loans, by law, we're kind of protected in that if we want to be able to get rid of our debt, we can do that and we can pay it off early without any penalty. We don't have to pay back more money just because interest rates have fallen. We can go back and pay it back, and then we can refinance at a lower rate. But that also means that, you know, some of those, the interest rates that we get have a little extra padding on them, because investors know that if interest rates drop in the future, home borrowers will want to refinance and pay off their loans early. So they kind of bake that into the initial interest rate. So it's a little extra high to compensate for that early payment of mortgages and stuff like that. So that's just a little side topic on you know, interest rates and how they're affecting bonds and loans and that kind of stuff today. So everyone's saying extremely hot today. Everyone keep hydrated. Yes, I will second that. Does coffee hydrate you? I don't know. I almost don't think it does. That's in the chat. Raheem, you have a question?
Yeah. Are we going to get a practice quiz again like we did last time?
It depends how early I get the quiz done.
Okay.
I'm not sure. I'm not going to promise it at this point.
All right.
The main thing was I wanted to get everyone used to how this quiz was structured and what the quiz environment would be like. So yeah, let me wait and see. Okay.
Okay. Thanks.
Mm-hmm. So let's talk about a zero coupon bond. As you can guess, the coupon rate on a zero coupon bond is 0%, right? But it's still a loan though, and you still have interest to pay back. But the difference on this type of loan is that everything gets paid back at the very end. And so at the life of the loan, let's say from an investor standpoint, an investor on a zero coupon bond that has a par value of $1,000. The way it would work is that the investor would actually buy the bond at a discount to par value. So instead of paying $1,000 for a zero coupon bond and getting $1,000 at the end, right? You pay something much less than $1,000. You get zero interest payments, but then you get the full $1,000 at the end. So your interest is kind of baked into the price of par value, and that change in the value of the bond is where your interest is kind of baked in. So here's an example of a bond. Let's say we have a 10-year zero coupon bond, and it's a 12% discount rate. And you can see the formula is already kind of up there. Boom, bada boom. So the key here on the cash flows on a zero coupon bond is you buy the bond, and then there's nothing all the way through the bond, and then right at the very end you get one lump sum value. So mathematically, to solve for the present value, all we really have to do is take the present value of par value to be paid in the future. And so when we calculate the value of a 10-year zero coupon bond, we're just going to use the equation you see here, and it's just the present value equation. That's all. So we've got par value right here, and we divide that by 1 plus the interest rate to the power of the number of periods. Interest rate's 12%, number of periods is 10, and so that ends up giving us $321. So what it's saying is, for this 10-year zero coupon bond, initially at time zero, you would pay $321, and then 10 years later, you would get back $1,000. No coupons in between. Okay? Okay, let's talk about bond yield or yield to maturity. Now, when bonds are first sold, they're created, companies work with investment banks, and those investment banks advise the companies on how best to structure the bonds, and they help the companies sell those bonds to investors. And the thing with the investment banks is they have contacts with all the big investors around the world. And so a company might work with one, maybe a couple investment banks, like the investment banks will get together in kind of a syndicate, and they will help that company sell all the bonds that they want to sell. One of the things that that investment bank will advise, when they sell those bonds for the first time, they design the coupon rate so it's just about equal to the anticipated investor required return, so that basically the investor required return will end up being our yield to maturity on the bond. So that's what they're setting the yield to. They're setting the yield of the bond, which is the total return of the bond if you were to hold on to the bond until the very end of maturity. They're setting that to what the current market is saying is a competitive rate. And I think there was an example last week where we set the coupon rate equal to the yield to maturity. And when we took the present value of that bond, it turned out to be $1,000, right? So when the coupon rate equals the yield to maturity, the present value is always going to be $1,000. So initially, when bonds are sold for the first time to investors, they typically sell right around $1,000, and they kind of auction them off, right? So it's not like you know, going to Amazon and just buying something. They typically get feedback from investors, and there might be some back and forth, but they try to make it so the bond will sell right around $1,000, and the coupon rate is equal to the yield to maturity. Now, one of the things we saw last class is after the bonds are sold and they're in the market, right? As interest rates change around the world, it affects all other existing bonds, and all other existing bonds will get reevaluated based on today's current interest rates. And so this will make, you know, bond prices fluctuate up and down. This whole time though, right, coupon rates of the bond stay the same. That's kind of locked in from the very beginning. So what we're going to do is we're going to look at calculating yield to maturity. And the way we do that is we take as an input the current bond price. If we know the current bond price and we know the future cash flows, then we can figure out what that discount rate of the cash flows is, and it's that discount rate that we call the yield to maturity for the bond. And so here's what the math looks like. You'll see the present value of the bond, right? We're going to set that to the current price. The coupon of the bond, we know how to get that. It's just the coupon rate multiplied by par or face value. Depending on how often the coupon payments are made, we may have to divide that by 2 if they're semi-annual, right? And then we divide by 1 plus R to the number of periods. And it's in this equation that we want to solve for R. R is the yield to maturity in this equation, okay? Let's do an example. What is the yield to maturity of a 5% annual coupon bond with $1,000 face value, which matures in 3 years? And assume the market price of the bond is $1,081.95. All right, so let's take a look at that. This is what the math looks like. Excuse me. The present value is equal to the discounted future cash flows, right? So we've got $50 as the coupon each period, and then we also have 1,000 in addition at the very end, right? And then we've got R, which is the yield to maturity or the discount rate for the bond. And we know that PV is equal to 1081.95. So we're gonna set these two sides of the equation equal to each other, and we're gonna solve for R. That's what this comes down to. But now you look at that and you're like, whoa, does anybody have any ideas on how to solve for R in this example? Let's set the PV equal to 1081.95, and that's not an easy one. And so here's the short of it. There is no closed form solution to this problem. We can't just use algebra to give us R equals, a certain number. And the way we have to solve this problem is to use something called an iterative technique. We do iterations of a guess. So we'll guess an R, plug it into this equation, and then calculate it based on the assumption for R, and see if we can get the top equation equal to 1081.95. If it's not, then we'll keep changing our guess for R until we get that top equation equal to 1081.95. So we have to keep guessing an R. That's the iteration. We go back and we keep doing it. And it turns out Excel and calculators obviously are really good at that. But for us, it could take a long time to guess a number, calculate the equation, and try to get them to balance both sides. So for this type of problem, I think you really have to use either a financial calculator, your graphing calculator, or Excel. So I don't have a good solution besides guessing numbers for math. In Excel, here's the solution. We'll use the rate function, which we covered before, right? And then we plug in the number of periods, which is 3 in this case, the payment, 50, the present value, and the future value. And then that gives us the rate of 2.15%. Hey, is anybody going to ask why there's a negative sign on 1081.95?
That's just for Excel.
Yeah, that keeps Excel happy, right? Because I know we've covered this a couple times, but it balances cash flows. So if you add them all up, the present value plus the future values, they kind of sum to 0. And so it needs to do that to do the math that it does, because in that above equation, when it's doing that iterative technique, right, it wants everything to sum to 0, basically. It's looking for an R, so when you add everything up above, it equals 0. That's kind of what's happening behind the scenes.
Professor, on this question, where do you exactly get the 50 from?
So the 50 is the coupon payment, the periodic payment that's made every single year. All right. And so we know it's an annual coupon, so it's once a year, and we know the rate is 5%. So we take 5% and multiply it by the face value or par value of $1,000. 5% of 1,000 is 50. So
okay.
We'll do another example of this in a few minutes, okay? And I'll pull out the old Excel, and we'll step through an example of this like this. In fact, well, let's do it right now. What the heck? Let's get crazy. And I see we got a question. Could you put negative 1,000 and positive 1081.95? Yes, you could. But you also have to do negative 50. So the key with the negative sign is you have to be consistent with the direction of the cash flows. And by that, I mean, think of yourself of buying the bond. And so when you buy the bond, you give up 1081.95. And so the cash flow is going that way. And then later on, when you get the first coupon payment, it's $50 coming to you, $50 coming to you, and then $10.50 coming to you. So the 50, the 50, and the 150, they all need the same sign. So that means you could put 1081.95 as positive, but then the 50's got to be negative, the next 50's got to be negative, and the 1050 has to be negative. So it's usually easier just to make the PV 1081.95 negative since it's only one number. Let's do this one right now. Everybody take a few minutes and go ahead and calculate the yield to maturity on this bond that we have here. It's a 5% annual coupon bond. The current price is $911, and you know that the par value is going to be 1,000, and there's 2 years until maturity. So go ahead, take a few minutes on your own there and calculate the yield to maturity on this bond. So we got a couple at 10% so far. Let's get a couple more, and then we'll see how we got the answer. All right. So in this case, let's take a look at it. How many periods do we have in this problem? And it's 2 years, right? Yeah, 2. And it's annual coupons, right? So we don't have to make any adjustments to the coupon or the number of periods because it's all based on a year. The cash flows happen every year, once a year. So we don't have to make any adjustments. So we got 2 years, which is 2 periods. The periodic payment we make every year is the coupon payment. And so that's the coupon rate, 5%, multiplied by the face value or par value of the bond. And so that'll end up equaling $50, right? And present value in this case, what should we put for present value?
Negative 900.
Negative 911. Yep, that'll do it. And then for future value,
1,000.
because that's what par value can be assumed to be on these, right? And that's what gets paid at the end. So that gives us our bond payment. So the first thing here, right? And you can, you know, when you type it in, it pops up with a little help there. And so the first thing is it wants is the number of periods. So we know that's 2. And then it wants the payment, which happens every period. That's going to be 50, right? And then we have the PV, followed by the FV, future value. So that should do it right there. And that should give us the yield to maturity on this bond. So I got like a 10.14%. So basically 10%. Now the default on Excel is it's gonna be 10%. So if you want to see more digits, you have to go into Excel and just click on this little thing here that increases the number of decimal points. Okay. Let's do one more example. I'm going to do everything the same as we did above, but now I'm going to throw a little curveball at you. And we're going to do semi-annual coupons. Okay? So find the yield to maturity on a bond with a 5% semi-annual coupon. So the interest rate, 5%, is an APR. So that is an annual interest rate, but the coupons are going to be paid twice a year. So that means we're going to have to make some adjustments. Current price of 911, so all that's the same. So let's go ahead and I'm going to give you a couple minutes again, and let's see what you come up with. But I'm going to tell you something right now. The rate that you're going to calculate is a periodic rate. So you're going to get the yield to maturity for a 6-month period, semi-annual, if you do the math right. But when we communicate yield to maturities to investors, we always do it on an APR, annual percentage rate basis. That means we take the periodic rate, like semi-annual, and we actually have to double it to an annual rate. Okay, so I'm going to leave it at that. Let's see how far you can get on the problem. Go ahead and do it, and then we'll talk about it when we in about let's say 3 or 4 minutes. So go ahead and work on it and see what changes when we go semi-annual. All right, looks like we got a lot of 5%. So here's what we're going to do. So let's calculate the number of semi-annual periods first. We've got 2 years, and we know there are 2 periods per year, 2 semi-annual periods per year. So we take 2 times 2, and that'll give us 4 periods. Okay? Because it's semi-annual. Let me know if anyone has a question. Now the payments, we found they were $50 per year above, but now they're going to come every 6 months. So we're going to take that annual $50 and basically cut it in half. So it's going to be 5% of 1,000, but then divided by 2 payments per year. And so that's going to end up being $25. Okay, 0.05 times 1,000, and then divide by 2. So let's do our rate function again here. So first we want the number of periods, so that's going to be 4 now, and we know the payment's 25. And we know the PV is minus 911, and the FV is 1,000. Okay, 5.01%. Now let me ask you guys this, guys and girls. The 5.01%. Over what time period is that? Yeah, 6 months. Now, if we want an APR, if we want this yield to maturity to be an annual percentage rate, what do we have to do?
Would it just be like multiplied by 2?
We're going to multiply it by 2. If you remember from our APR, we take the periodic rate, right? And we multiply it by the number of periods per year. Something like that. And so for us, that means it's going to be equal to 0.0501. That's 5.01%, right? And then multiply it by 2 periods per year. Equals 0.1002. So this is the yield to maturity that would be communicated to investors. Okay, and it turns out that's the way pretty much all loans are, even consumer loans. So like if you were to look at a mortgage or something, the mortgage interest rate that you're looking up when you go to get quotes is an APR. But the loan itself is going to have monthly payments. So the loan is going to use a monthly periodic interest rate. So you would have to take the mortgage quote, an APR, and convert it into a monthly rate to do all the math and to figure out your payments. Okay? I don't think the homework has any of these little gotcha problems, these yield to maturities for semi-annual coupons. Unfortunately, I think I forgot about them on the homework. So that'll make it easier for you guys. Any questions about that? Bond yield to maturity? All right, I'm going to jump back to the slides. Let's take a look at the yield curve. So the yield curve shows the interest rate at different terms. And by terms, I mean like the length to maturity for different bonds. So like we have a 1-year bond, a 2-year bond, a 3-year, and so on. And so the yield curve shows, they call it the term structure of interest rates. Term structure of interest rates is just how interest rates are different over time. And together we call this chart the yield curve. And this is what the yield curve looks like. The black line is data that I pulled last week. And the red line is data from back in 2008. And if you look at that, wow, it's pretty surprising how much interest rates have changed. And you can see that short-term interest rates. So down here in the chart, these are short-term rates. Like anything 1 year and below is short-term. And then it keeps going all the way out to 30 years. So 30-year is about the longest I think the US government sells bonds for. It turns out, if you were to look at mortgage rates, actually mortgage rates are most closely tied to 10-year government rates. And that's because most mortgages, people don't hold on to them for more than 10 years. The average is right around 10 years because a lot of people sell their homes before the end. They don't reach maturity. And it's pretty crazy how low it is. Right now, 30-year rates are around 1.5%, 1.6%, I think. Yeah, and a lot of this primarily has what has really driven the stock market to do so well since March, is because the government took actions to bring down interest rates in the marketplace. And you can see that in this chart. So what this means right now, like for you as an investor, if you were to invest in bonds, you're going to get a very low interest rate. If you were to, let's say you bought a 30-year bond from the government, and it's not even going to pay 2% per year. Does anybody have an idea of what inflation is running around right now? Just throw out on the chat board or anything if anybody has an idea what inflation runs about per year. I'll give you a guess. It's usually somewhere around 2 to 3%. So I got a deal for you. Give me your money. I will pay you 1.6% per year for 30 years. And oh, by the way, inflation is going to be 2 or 3% per year. So what that effectively means is the value of your money is going to go down every year in terms of purchasing power. And so that doesn't sound like a great deal, right? And so basically by forcing interest rates so low, it forces people to put their money elsewhere. Either they go buy stuff, cars, homes, appliances, to get the economy going, or they buy stocks. And that's why the stock market really has done so well, is because the low interest rates have effectively forced investors who are shopping around for the best deal to buy stocks. So that's the yield curve. And typically it does slope upward like that, such that short-term rates are lower than long-term rates. That's the average. but it does change over time. But what you see here is kind of the average upward sloping yield curve. So how do you calculate the return on a bond if you sell it before maturity? Right, because these are publicly traded, and there's nothing to say that you have to buy a bond and hold it to the very end. Now, before we look at the equation, I will say this. The yield to maturity is your average annual return if you hold on to the bond until the very end. Okay, so that's a really good answer to a good quiz question, if you will. I'll have to write that down. But so that's, you don't even have to calculate that. If you hold on to a bond until maturity, your return every year on average will be the yield to maturity of the bond. Excuse me. But what happens if you sell the bond before maturity? This is the equation we use to calculate that. You're going to look at the return you get over a period of time. And in that period of time, you have to take into account two things. You have to take into account the coupon that you got, any interest payments you received, but also the change in the price of the bond. So for example, hopefully the bond price went up, right? Because that would be good for you. So that's an extra return. If you sold the bond for more than you paid for it, that's an extra return that we should take into account. So the rate of return of equation basically takes into account any coupons you received, the interest, the change in the price that you got divided by your initial investment. Another way to think about that is that it's the coupons you receive, and the change in price is basically the price you sold it at minus the price you bought it at. And so I call the price you sold it at price at time 1, and the price you bought it at as price at time 0, the initial price. And you divide that whole thing by the initial price at time 0. I'm gonna flip to Excel again, and let's go ahead and do an example of this rate of return. Boy, it's starting to get a little warm where I'm at. Okay, so here's the question. Assume we purchase a bond for $911, and then we sell the bond 6 months later for $1,000. And then assume that during those 6 months that we owned the bond, we collected coupons of $30. So let's calculate the rate of return over that 6-month period on this bond investment that we made. Right, so rate of return, and we know it's any coupons we receive plus the price we sold it at minus the price we bought it at, initial price, and then all divided by the initial price. And so if we purchased a bond, this is going to be equal to P0 up here. Okay? And when we sell the bond for $1,000, that's going to be P1. Okay, so let's go ahead and calculate this. happy. Oh, smile, bad face. So we got 1,000, right? Minus 911, all divided by 911. So what do you guys get for that?
I got 0.1306, which is like 13%.
There you go. That's what I got too. All right. So the key here is that, you know, it's not just the coupons when you're figuring out returns on bonds, right? Don't forget about what we call capital appreciation, the change in the value of the bond itself. And so in this case, it's you know, it's pretty significant. Okay. You know what? I think I'm going to save. I'm going to save the next couple slides for Wednesday. Okay. The bond and credit risks. Let me do I'm going to do another example now because I think there was one slide. I think was it zero coupon bond. Let's do an example of that. I don't think we did one in Excel for that. So that's it for the slides today. I'm not going to cover any more. I want to get a little bit more practice calculating stuff. So, okay, so here's the question. What is the present value of a zero coupon bond with a yield to maturity of 12% and a par value of 1,000? Assume the bond matures in 5 years and that compounding is annual. So go ahead and take a couple minutes to work on that problem by yourself, and then we will come back and solve it together. All right, so what's our rate here?
Would it just be 12%?
Yeah, and we're told compounding is annual, so we don't have to make any adjustments to it, right? So I'm just going to put in 12% for the rate. How about the number of periods?
5.
Right, no adjustments. It's annual compounding, right? Yep. And how about the payments?
0.
Why 0?
It says 0 coupon bond.
Ah, very good. And how about future value?
1,000.
1,000. Yep. Yep. Not a trick question. Okay, so let's go ahead and build this then, right? So, so first off, we need the rate, right? And then we need the number of periods. And then we need the payments. And then the future value. And so that would be our solution right there. And you'll find that most people in professional settings, when they do spreadsheets, they put all the numbers in kind of a separate table, so they're easy to see and change. And then the actual formulas might be in a different area, and they link to the numbers within the formula, like I did just here. So instead of putting, the rate is 0.12, I just pointed to cell B5. So I got 567.43. And the nice thing of organizing a spreadsheet like this, where you put all your assumptions up near the top, is that invariably you're going to get questions, well, what if some number changes, and what does that do to our answer? So in this case, like, okay, what happens if interest rates go up? So they're at 12% now. If they go up to, like, let's say 20%, what does that do to the price of the bond? Ooh, it drops to 401, right? What if the rate goes up to 0.3? Wow, it drops even more to 270. So, so that's the nice thing about doing your work like that. In a test situation, you probably don't want to do that. It maybe takes a little more time, but still, writing everything out like this kind of helps you structure, because you've seen by now, with all these time value of money problems, right? There's 5 pieces of information. There's present value, future value, the discount rate, the number of periods, and the periodic payments. And typically you have to find one of the 4 and you're given the others. And so if you write it down like that, it kind of helps structure your thinking on how to solve the problem. All righty, let's see. I'm gonna open it up to questions now. So I'm not gonna cover any more new material or content today.
Professor, how do we know where do we put the negative sign in?
So there is no one answer for that. It's kind of your choice. But what I usually say to do is just put it on the present value and then leave all the future cash flows positive. Later on, we'll cover problems where cash flows are mixed, positive and negative. They could be anything. But for these problems, the way to think about it is you're buying a financial security, right? And so if you pay for it up front, that's a negative cash flow. So that's negative at present value because you pay money for it. But then in the future, you get money back to you. That's a positive cash flow. So that's the way I like to think about it. So I always make PV negative and all the future cash flows positive when we're looking at, bonds. But technically, we could have made PV 911 in this problem I'm sharing. We could have made that positive, but then we would have had to made all the future cash flows negative. So the key here is, how do you know? Well, you just have to be consistent, and you have to define which direction cash flow is negative and which direction is positive. And the way I define it is that when I, the investor, pay out money, that's negative, and when I, the investor, get it back, that's positive. So that's kind of how I define it. But you know, as long as you're consistent in how you apply, like if you want to say, when I pay money out, that's a positive cash flow, you can do that. But then you have to be consistent and say that when money comes back to you, then it's a negative cash flow. And as long as you're consistent like that, and you make your definition up front and follow it all the way through, you're going to get the exact same answer.
Right, right. Nice. Thank you.
Have a good day.
You too.